Hello guys, and welcome to another data recovery video. This time I'm working on one of these little SanDisk USB sticks, and this one happens to be a Cruzer Blade 32 gig. And if you're new to the channel, welcome along. I'm a data recovery engineer, and people mail me in these USB flash drives from all around the country, and it's my job to get the data back for them. And if you can see here, this one's pretty obvious what has happened. It's been cracked through the connector. And this is a USB A type connector. And it has torn all the way through this bottom side. The little PCB is cracked. It's taken a lot of force. So the obvious thing is that a lot of these wires here have been damaged. If we flip it over to the top side looks okay. It looks like the little trace wires on top of the PCB are okay. Now there's 4 pins to USB 2.0. We've got a ground pin, we've got a 5-volt power pin, and then we have a differential pair. That just means that both these wires send and receive the same signal, but they're inverted. And what happens is the host controls the USB stick. That means that whatever this is plugged into, such as the PCB, the host will control what this has to do. It just has to listen and obey. Now, differential pair means one wire goes high while the other one is inverted and it goes low. And USB 2.0 is also half duplex, and that means it will only send a signal in one direction at one time. So it'll either be transmitting data in one direction or receiving, and that is it for a differential pair. So I am looking to see what is happening with these 2 data lines and the 2 power lines to see if I can resurrect this thing to get the data back. So to look at this crack more carefully from the top, I want to make sure when it is connected that I can see what is happening. So this pin here, I believe that's the power, it goes through to the other side, and that looks undamaged. This pin here looks like the ground side, and it goes all the way through here. So there's a large ground plane there, and here we got the data line. So one in here, and we've got the trace wire where it goes through this hole to the other side, and it's undamaged. So it looks like most of this work will be concentrated on this side of the PCB. So on the bottom side, we can see these 2 little holes where the data lines come through, and actually they might be okay. It's hard to tell. I will test them. You can see the little hole here, and the trace wire connects to the controller. Now keep in mind, if there's been this much force that can crack this PCB, then it is possible that that force can crack other components, so I do have to be wary of that. Also, here's our 5-volt input line. It's quite a large trace wire going to here. That should be easy to fix. I'll just scratch that back and re-solder that. Same with the ground. We got ground here completely broken through, ground here broken through, ground here broken through. Looks like we might need all that re-soldered because it looks like there's little things possibly feeding into that. So the first thing I'm going to do is I'm going to solder on this little wire to these data lines just to make it easier for me to test if they're still working or not. And at the end of the day, if it is damaged, it'll be also easy for me to repair. So let's just tack a bit of solder down the bottom here. I want it down the bottom because I don't want it in the way once I get this to work. So couple of bits of solder. I'm just going to use this little test wire, might use the other side, and I am going to tack weld it to this pin, data pin. Now it's very delicate, the microscope is zoomed in quite a lot, so it's hard to play with. I just want to be very careful with how fragile this is. So now that we've got the top hole going in there, once I flip it, it's going to be the bottom one, obviously. Okay, so I've got the multimeter in continuity mode, and I'm going to probe and see if this is damaged or not. Hopefully it's not. That will make life easy today. So what will happen is the multimeter will beep like that. It's now the bottom one, so we'll trace it to the input pin of the chip. And that's good news. That means that one is working. Let's test the other data line. So we'll just move our little test wire, heat him up. It's hard to get down here at this level. There we go. Same again, let's flip it over. Now remember, where were we? Bottom now becomes the top. Okay, we're just going to touch this pin here. Okay, that's good news. So it means that these two data lines are undamaged. So let's fix the power now. So to fix these trace wires, I need to remove some of this coating and expose the copper wire. Just enough to get a good solder base to solder that wire on. I'm just going to carefully scratch back. You want to be very careful to stay in the bounds of this wire, this trace wire. Now, same with the ground. What should we do with the ground? What I might do is I'll go from the ground inside here and then test if all the other sections are okay. That will save me time with soldering. For my ground section, I'll just use in here because it looks like it's going to be out of the way. Cross-hatching back and forward. That should be enough solder there. Okay, so now I've got two options for the power for this. So the 5-volt line here, what I'll do is I'll solder a bridging wire from here to here. Now that's a polyfuse, I can tell that because it's green and it's got an E marking on it. You usually see E or F. And a polyfuse is a resettable fuse. It means the more current that goes through this, the bigger the problem, the more heat it generates and it'll stop working. It'll protect the circuit. And once it cools down, if it's not drawing excessive current, well then the fuse resets and opens again. So we'll go from here to the polyfuse, and for the ground I'm going to solder from here, and we've got this diagnostic printout here, so I know that the second pin here should be ground, and that'll fix this hopefully. Let's start with some flux here, here, and off camera, no, on camera, here. And we're just going to put some solder balls on. I'm just going to top up this polyfuse so we can piggyback its footprint. Oh, that is hard. There you go, that should be enough. And down here, the footprint. Perfect. Today for the repair, we are going to be using some enameled wire, and I've got some very thin stuff. I can't remember what it is. I think it's like 0.3 millimeters. Sorry about that. It is enameled. I might cook off the tip first. And to do that, I'm just going to put it in some solder. Now we need to cut it off to length, which is there. Did I get that? Whoa. That one looks good. Just while I've got the PCB all facing the one direction, I may as well do this one as well. And we'll just melt the enamel off this wire. Probably the fastest and easiest way to do that. I've got all the other tools and they suck. So here we're going to solder there, and we're going to go to here. probably a bit long. I'll trim a bit of that off. Okay, much better. Now, since we're here, I think I'll do this one first. So we've got enameled wire. I might just melt it first by... There we go. That looks good. Same with this side here. Perfect. Now, instead of using my fat fingers, where's my little micro tweezers? Here we go, this will do. How does that look? Is that a bit too long? It's a bit long, I might have to... Yeah, it's too long. Sorry about that, guys. Let's use tweezers. Fat fingers suck. Let's trim to about... That's better. Now we just got to fix the... Alright, I'm just going to melt the enamel into the solder. No, I won't. That's too difficult. Let's stick to my tried and tested method, which is to melt the enamel. There we go. Clean the tip, because we're doing the proper live weld. Beautiful. That looks good. Now, we've got the same one up here. That looks like it's sold a bit out of focus. There you go, you can see it underneath. We just need to get the data off nice and safe. There you go, guys. I'm pretty happy with that. It should work. Let's clean it a bit before we power it up. Let's spray some ISO on it, and we're going to be very gentle with how fragile this is. We're just going to clean away a lot of this flux and soldering. That looks good. I've cleaned it up. It's ready to be tested. Now, keep in mind, I'm not going to be surprised if it doesn't work, because anything with this much force to do this much damage to a PCB can easily crack little things in chips and the memory chip. So let's plug it in and hopefully it works. Okay, that's what it looks like. I've put it back in its little case so it fits correctly in the USB socket. Hopefully it works. Okay, so we've got the USB connected to the computer. We're going to do a test and see if it responds. And it is thinking, and there it is. As you can see, SanDisk Cruzer Blade USB device. And it's got the correct capacity of 28 gigs. That is lovely to see. So good news. Let's see if we can get the data now. And there it is, guys. We've got access to all the data again. Another successful data recovery. If you have a USB flash drive that is broken or not working, you can mail in anywhere around the country and I will get your data back. Hope to see you guys in that next video.